in terms of grading. So I'm going to read through what those criteria, what the protocol is, and that's in the first tab. The second tab, notes, is our actual material, but I decided to write that because there's a lot of drawings, and I didn't want to waste your time doing all the drawings in class. So I tried to make a nice set of drawings, and that's why the notes is pre-done, and the code as well. The code is not, it's for a very specific purpose that I'm showing you some code, but we'll get to it later. Anyway, so we're going to read through, well, hopefully all of them. Start off with the paper choice. All right, so the idea here is that as a researcher, activities that you eventually are involved in, first of all, you have to read other papers beyond research papers, beyond the knowledge that you know or the textbooks that you've read. You need to constantly update your knowledge set. When I taught software engineering, so I would do the code of ethics, and that was one of the hallmarks of the code of ethics. There's a number of them, 8 principles of ethics that a software engineer has to sign before getting an official certificate that they are a certified software engineer. They have to sign that they adhere to the code of ethics. But one of them is the improvement of self-knowledge. So the only way you could do that, well, I mean, if you read up more and more recent papers, and research papers, and also, well, we don't necessarily do it this way. In the medical field, they have ME credits, medical education credits, and I think you have to do 30 credits of online courses or in-person meetings every 2 years, something like that. So you have the continuity of education. You have to constantly learn, study, update your knowledge. Anyway, so in the research field, that's important to keep up with the trends and what are the important problems people are working on. In addition, if I were to write a paper and publish it, I would also probably give a talk on it, in which case you would write up slides in a PowerPoint, and that's the idea here. Now, you're not doing your own research, writing up your own paper. We are going to make, in this one detail, going to make believe as if you wrote the paper that you chose. We'll talk about how you choose, quote unquote, the paper selected for you, by you, and or for you, as we'll see. Anyway, the bottom line is that's the idea. I would like you to have the experience of reading someone else's paper, research paper, as well as presenting it by summarizing that paper in slides. Now, the actual protocol of how to do the slides, I'm not going to do with you today. I will do with you in a week from now, after hopefully all the, if not all, most of the paper selected have been received and approved. So today we'll only talk about how you choose and the protocol you need to follow. So I'll read it with you. Line 1, choose a peer-reviewed research paper that is published in either a conference proceedings or a journal article. All right, so concept of being peer-reviewed. Peer means your colleagues, but it doesn't really actually mean your colleagues that you know. The idea is actually that people that you don't know, or at least are willing not to tell you that they are, that they're reviewing your paper, because you want some sort of objectivity when analyzing the paper and determining whether it's worthy of being published. Now, in terms of where to be published, as I will say shortly, so in the advent of the web, you could self-publish, which is not allowed for this. It does not meet the criteria. Not that it's not allowed; it doesn't meet for the criteria. But here, so it's either going to be in an actual journal that you can go to the Queens College online or in-person library. Either way, my QC has access to the library and the journal articles, and lots of scientific databases and journal articles are there. You got to be careful with archive.org, I believe it's called. It's a wonderful site, but as I said, people could just dump things there and you won't know. But if they give you an appropriate citation to where it was published, then you can determine that it's legitimate. Anyway, conference proceedings. So in some fields, conference proceedings actually count more than journals. In some, not most, in some fields. The reason for that is as follows. The process of reviewing a paper and the process of reviewing the paper and getting it back to the author and asking the author to do revisions until it's finally published is something that could take up to 2 years. It just does. If it's done correctly with a real journal, it takes time. And in the case of the conference proceedings, you may want to get the information out there right away. So there are talks every 6 months. There are major conferences almost about every 6 months in different countries and different localities. But that's the ability to get the word out about this new exciting research or data that you found or that some conclusion you arrived to, whatever. So the conference proceedings are a venue of the quickest venue to get information, but is not as necessarily as rigorous in terms of review. But the journal articles are supposed to be more rigorous in that. But there are, not to minimize it, there are conferences and their published proceedings. Proceedings is just their publication of the conference papers, compendium, put together. Collected together. But there are conferences that are very highly respectable and highly reviewed. So anyway, all right, line 2, no survey papers. Not that survey papers are bad. Survey papers on a field or broad topic try to summarize concepts found in as many papers as possible, but they don't concentrate on any one topic or any one approach. So they're not really research. They're very helpful, because they tell you in a summary what's out there, but they aren't necessarily research. Okay, nor book chapters. Again, line 2 on the notes projected on the board here, as it were. Nor book chapters. So book chapters are a little bit more interesting. Admittedly, books, chapters and books could be research papers and valid ones, etc. Generally, they are more of a survey paper and or invited paper, not necessarily peer-reviewed. So sadly, a book chapter is actually less reviewed than an article. But more than that, independent of that, the previous times that students have suggested that they wanted to do a presentation of a book chapter, they were not able to find reasonable book chapters. They thought, book chapter sounds real fancy, but it wasn't in practice. So just for simplicity, not to get involved that students have to redo it or rethink things through, I just say no book chapters, which that's not the common venue. So even if you to find some book chapter that may have a research component to it, they're not. Most books aren't that way. Most books are surveys or older or whatever, a summary, whatever. It's not important. Anyway, nor book chapters, fine. Nor review papers. So review papers are similar to survey papers, but review papers are usually more targeted. So they review the material. Certainly if they just review a book, that's certainly not the case. But they generally are not trying to present research of new ideas. Research is really about the testing. Okay, now also no self-published, as I said on the web, anyone published somewhere, right? No self-published papers. Even if found on an educational website, or even if a department website has them, such as what's called technical reports. I don't know if people still do it, but there are for many years, departments, computer science departments at large, would have a venue of quote unquote published material, but it wasn't really may have been quickly reviewed, but it was done by colleagues who really were interested to publish to put out your papers, not really considering the rigor of the research per se. So it's not necessarily very high quality, but these technical reports were then submitted to journals and then eventually published in a modified form. So if you find the paper in the journal, because you read a tech report, so that itself is not acceptable for this PowerPoint presentation and reading of the article. But if you do find such a technical report, look for the same author and the same title, and very often if they're good enough, they will have been published somewhere legitimately. Anyway, so it's like a self-publication. It's just not typically on the quality level that a real research paper was at. So any self-published papers or even technical reports are not considered. Reports in general are not considered. Either surveys, summaries, or just not reviewed. All right. So now the key. What's the main idea? What's the key criteria that you want to consider your papers about? So line 4 says for this course. Again, some of these details are different from my other courses, but because of the nature of our material, because we're so theoretical, so some of it's not as easy to find. But anyway, so it's worded differently here. Lines 4 and 5. The topic of the paper must be some application of automata to some practical problem. That's what your paper has to be. It has to involve automata, abstract machines, Turing machines, but I didn't restrict it to Turing machines, so I'm allowed to, because otherwise it'll be too limiting. So anyway, some paper application to some practical problem. Someone has a problem and they modeled their problem by using automaton or automata plural, and they then are going to try to solve their problem. That's what the paper is about. Well, yeah, but that's true, Elio. Every computer is Turing machine equivalent. But we're talking about abstract automaton, the hierarchical automata. When you say automata, you mean the abstract automaton, not the hardware-based. No, I'm sorry. Okay, so you're dealing with the finite state automaton, push down automaton, linear bound automaton, and finally Turing machines. Of abstract automata to some practical problem. Okay. No, because otherwise you're right, Elio, but that wasn't the idea. All right, James writes, so we have to find some problem that needs an application of abstract automata to solve it. Okay, you can do it that way. You can go the other way around, but yes, that's right, yes. You have all the components, James. I don't know if you should leave the problem and then how to solve it or go around the other way. It's about automaton and see which ones solve problems, but that's up to you. But yes, in essence, correct. Okay, another criteria which is quite important. There must be at least one diagram, figure, and or table in that paper that you're reading that depicts how automaton helps solving a problem. Okay, because otherwise it'll get too theoretical or too wordy. It has to have some sort of figure or figures or diagrams or tables in that paper. If it's just talk, then it's not acceptable. That's line 5. The PowerPoint presentation that you'll be preparing, that your PPTX, is presenting the paper you are assigned to, and we'll now talk about how you get assigned. And then we'll talk about how to submit, but for this part as well. All right, now, so let's see next. Okay, next paragraph, line 8. You must obtain, so your assignment you'll have a week to do this. You don't have to write up your whole presentation in a week. The assignment is just to find papers for potentially, which I will then acknowledge that is your paper to read. Anyway, that's the assignment, to select the paper, choose the paper. You must obtain 3 papers in PDF format only, okay, PDF, and submit the actual PDFs in one email from your email to the class email. Papers submitted will be processed in a first emailed, first served basis, dated by the order in the class email. And that's quite important because if somebody submitted the same papers, for example, because you're all doing similar searches, and then you submit it, so I'll have to say to you, sorry, these papers are already taken, which I'll have to explain why, but I think I wrote it somewhere, if not I'll have to explicitly state it, which is that each student is going to have their own paper. I do that for security purposes. No 2 students have the same paper. All right, so now, these PDFs must be manually attached to your email, manually inserted or attached, as opposed to sharing a link URL or sharing a cloud file due to various security concerns. So I will not consider it submitted if you just give me a URL to the file, a link to the file, a shared file, cloud file, in which case it's also a link, even though you don't think it is. It has to be manually inserted and attached. Otherwise, these papers, oh, here we are. Otherwise, these papers are not considered submitted, which means no one else can grab them first. Must submit 3 at a time. Suggest order of priority. I'll try. I will tend to try. I'll consider. I'll read. I'll try to look at the papers in the order you tell me. That's what I mean. Suggest an order of priority from the one most interested in to not as much interested in. The papers must have been published in the last 25 years. Okay. Now, and then alongside the PDFs that you're submitting to, you must include in the email body the bibliographic reference to the papers you are submitting. Do not include URLs. Okay. Now, every paper cites other papers, and the author or authors will put a listing of these papers in a reference section, bibliography section at the end of their paper. That's not what I'm referring to. And that's emphasized in line 23. When I'm finished this example, I'll repeat it in line 23. That's not what I'm referring to. What I'm referring to is that your paper was the papers that you are attaching by PDF. They are published somewhere. I want you to write the reference to where that paper is published. So imagine this was a psychology course. And imagine Harlow's of 83 was 2003, because I said only the last 25 years. This example I probably got from the APA website or somewhere like that. An example of such a reference based on the APA style for references. APA stands for the American Psychology Association, and for most people that is the standard style of how you do references. So assuming you selected the following paper, okay, assuming you selected a paper entitled, let's add that, make it a little bit, a paper entitled, the name of that paper is Fundamentals for Preparing Psychology Journal Articles, then the reference is as follows. The author happened to be Harlow, published in 2003 and 1983. Again, you have to do it the last 25 years. And then you write in quotes the name of the article, Fundamentals for Preparing Psychology Journal Articles. Okay, then you write the journal, the name of the journal, the volume of that journal. The journal spans many years, so there are volumes. And then PP stands for pages, the numbers printed in the journal. So this is volume 55, pages 893 to 896. Note, a small note, the word volume, VOL, is also known as issue. Some journals call them issues, some journals call them volumes. Further note that the way you write this volume number differ. Sometimes it's based on the year. So some volumes are like, for example, 2022-7, which is the 7th binding in the year 2022. Some of them do it based on seasons. So the issue or volume may be 2022 spring, and some of them do it if it's monthly. Sometimes they'll do it in months, 2022 March. Okay. We are following APA style references. Okay, so that's to review. Note. Only one bibliographic reference to each paper is requested, and that one must have the name of the paper contained in the PDF as part of it. The name of the paper that you are storing in this PDF or you're downloading in PDF form, the name of that paper must be in that bibliographic reference. That's how you know. If you copy the references at the end of the paper, the name of your paper is not there. That would be self-referencing, and that's not allowed. So the name of a paper is not cited in the paper itself. We are looking for that paper with that name where it would be published. Think of it as if someone else is citing your paper. What would the bibliographic reference look like? And that should be included. So you must submit 3 at a time, as I write at the end of line 11. In addition, you must cite with it the bibliographic reference of that paper. Yeah, okay, so now James asks, each bibliographic reference to each of the 3 papers will be a PDF? The reference won't be. No. You're doing no URLs. The papers themselves are PDFs. They'll be attached. In addition, the body of the email is going to list numbers 1, 2, and 3, and it's going to have the reference. Okay, James? Yeah. Okay, Natasha asks, so we need to submit 3 papers, correct? We will find correct, to the class email first. With their bibliography reference, correct? With their bibliography reference, and I will assign one of those three back to you. Correct. That's right. I don't actually say that. Okay. I don't know. I don't know why I never said that. Okay. Let's see where to put it. Let's put that. But yes, that's the idea. You are quite correct, Natasha. But let me see this here. Okay. Okay. That's not where I wanted to put it. Great. Okay, that's better. I wanted to put this here. Let me put this here for a second. And let me put that here. And let me put this over here. Oh, what did I just do? Okay, let me just read that over for a second. Give me 30 seconds. Okay. Thank you for your patience. Let's see here. Good. So then, no, I keep moving. My mouse keeps jumping. That's why. Okay. Let's just add this last piece, and then we're done here. Assuming one, no other student has already been assigned that paper. 2 papers follow the above guidelines. Not just above the guidelines in this in this tab. Good. All right. Sorry. So yes, Natasha, thank you very much. I didn't even realize, Natasha, that I had never wrote it up that way. So I apologize, and thank you. All right. The presentation, the actual presentation. Okay. The actual presentation, which I will discuss how to when most students have submitted their selections, their choices. So we're not doing it today. Will be submitted on PowerPoint PPT/X. That's the Microsoft designation for PowerPoint. Each student will be assigned a different paper on a first-come, first-served basis. Speed up selection process. Submit the 3 manually attached PDF files. With bibliographic reference to the individual papers in one to each individual paper in one email from QMail to class email, and not uploading it to the Blackboard system for this task. It would slow things down terribly for this task. Good. This has to be done by March 15th, or I will have to deduct points. Again, this will be submitted by March 15th from QMail class email in one email. All right. Okay, so I fixed a little bit up. I thought it was already all written up. All right, so that's the idea. Natasha and James summarized it correctly in the last lines. All right, very good. So that is the first tab. Okay. One last note here, which I'm not going to write because it's not necessarily going to happen, but it does. It has happened, of course, that one or two students I may have to ask you this, or a few students, to please submit again. That's not a punishment. I'm not. That doesn't mean that what you did wasn't good work. It just there are two factors. Well, as I wrote on line 14 now. One is that no other. It could be you wrote excellent. You chose excellent papers, but by the time you completed your research and submitted, three other students grabbed the papers already. And since I'm only doing one paper per student, meaning uniqueness, a injective mapping, as you learn in discrete math, has to be unique. So therefore, I am not. That's it. So then the papers were taken. You'll have to do it again. The other situation is simply that it doesn't follow all the criteria. Usually I'll give a summary reason why not. But there are also, I'm assuming good faith, assuming you can play a game and just not do the work, but you tried. So I'm good, so it didn't work out, and now we do it again. So what? It may be, well, in some cases, but that's very rare. One student had to do it 3 times. 2 times does happen. Most people get it on the first shot. Okay, so that is the first tab. Okay, now comes the notes. So let's talk about the material of today. And the topic is recursion. Oh, I'm sorry. There's a question here. James says, after we submit the 3 papers, it says each student will be assigned a different paper. That's right. Will that topic come? Yeah, no. I just said to Natasha here under line 13. After submitting the 3 PDFs with the required 1 bibliographic reference to each, right? And explain next. I'll assign the student one of these papers selected. You should add a little bit. Just let me clean this up. After with the required 1 bibliographic reference for each paper submitted. I will assign to the student one of those papers submitted. Okay. Assuming the following. That's fine. Okay, something like that. All right. Yes, that's right, exactly. No problem. Today's topic is about recursion. So I want to add one line, which we did like the first week of class, second lecture. A major name for this course, or this field, course, whatever you want to say, theory of computing, is recursion theory. I played that down till now because we're going to embark for the next month or so. We're now going to embark on much deeper levels of what recursion really is than you've learned in any other class. And maybe after the fact you would say, do you really need to understand those deep levels? I think so, because I think it's going to, if done correctly, could give you a certain strength in analysis of algorithms. But anyway, a lot of things are recursive even if you don't realize they are. A major name for this course or field is recursion theory. So the question is, what does recursion mean? Law 2. So the colloquial, again, as I write the source colloquial definition, the colloquial definition is a function that calls itself. Right? What is recursion? A function that calls itself. Okay, I put an asterisk there because at the end of the lecture, this definition is not sufficient. But that is what people say. People say, what is recursion? Recursion that calls itself, and a little asterisk at the end here of this line too, to be discussed below towards end of lecture. What's potentially missing from this definition? Okay, so now another. Well, I call it the dictionary definition, but it was a standard geeky humor. Imagine the following definition of recursion in a dictionary. Recursion. See recursion until you understand. I love it. So that is recursion. And the joke here, of course, is the until you understand is the base case. So if you say see recursion, you have an infinite loop. Oh, actually, I explained it. I didn't realize it. Okay, until you understand is the base case. Otherwise, you have an infinite loop. There you go. I really didn't realize I forgot about it. All right, so that's the simple intro to base case. Oh, yes. Recursion is a, let me explain that. Recursion is a, where am I going to put it, though? All right, fine. Recursion is an inductive method. So the base case. That's a non-recursive step. Okay? Does that help you? About induction, because it's going to give us great insight to recursion. But do you now understand that comes from discrete mathematics, the notion of a base case in inductive methods. Oh, I see. Okay, got it. Now I got it. All right. Now. Oh no. Yeah. So that's odd. I gotta be honest to you. When people talk about a function that calls itself, it is missing the base case, and no one cares about it. It's weird. I know. That's why I added until you understand. The joke is the actual joke is recursion. See recursion. I added until you understand. But the people who colloquially say recursion, a function that calls itself, do not talk about the base case. I know. It's sad. But that's not what's missing. I know it's true. What you pointed out is missing until the base case, but that would be at the end. Something in the middle on where calls is missing. Yeah, I'm going to leave it alone because people colloquially talk that way. Not that it's necessarily correct. All right, now. So what's actually, first of all, the perspective we're going to take today is from the operating system perspective, which is how things stored in the memory of the machine to enable and help out with the recursion. Well, yeah, but you don't have to say it as part of the definition, because the amount of memory used is not mentioned at all. It's something else. At the end, we'll see what it is. All right, so just a little terminology. There's the memory pool is actually called a heap in operating systems. The fact is, I mentioned this tangentially, but it's worthwhile to know that the word heap in computer science appears in many different places, nothing to do with each other. Okay, a little water break. All right. So for today, the lecture, for today, what I mean is what we're using, the context that we use heap today. Number one, the heap is a pool of memory maintained by the operating system memory manager to provide dynamic memory to processes during runtime execution. Right? Nothing runs in ether, as they say, this ethereal gas, which the Greeks, whatever. Anyway, you can read about the ether. The point is that the heap, nothing in the computer runs in the air, in the electrons. It runs in the hardware, and value must be stored in memory. So everything that runs during runtime execution has to be somewhere in memory, and that place of memory that the operating system has available to all these runtime processes is called the heap. So that's the operating system dynamic memory manager. Okay. Now we also know heap. You probably have learned it already, either in data structures or languages, so analysis algorithms for sure. Heap as in heap sort. But that notion of a heap is a binary tree whereby the value of the root is consistently either greater or less than all its descendants. Okay, so the parent is always either consistently greater than, greater or equal to all its descendants, or less than or equal to all its descendants. Max and min heap. All right, but that has nothing to do with number one. It just has to be called the same name. Then you have Heap's algorithm for recursive non-recursive generation of permutation, or of permutations. That is Heap's algorithm. And finally, you have another Heap's algorithm. The latter two may be the same person, but people generally call them Heap's algorithm. But anyway, Heap's algorithm in graphics for contouring lines over sets of points in graphics. Anyway, those aren't as important to us. The point, though, is number one, heap is a memory pool. I'm just saying the name heap does appear in the literature of computer science in many different situations, and they all mean different things. And one last interesting note, there are those, I'll put in parentheses, there are those who call what's called, and I'm not going to explain it now, take operating systems. There are those who call the buddy system structure used in some operating systems a heap because it has elements of the first two heap definitions here, number 1 and 2, of being a pool of memory, as well a virtual pool of memory, as well as being a tree mentioned above. But in reality, they aren't completely either of them. So the buddy system, some books call the buddy system a heap, but that's not really exactly what the heap is. All right, anyway, it has elements of 1 and 2, though. All right, so in the heap, now let's see what's in the heap. So in the heap, there are what are called blocks of memory. Each, and that's an official term, blocks of memory, each assigned to a different running process. Historically, these blocks of memory are also called pages of memory. There are reasons why, but it has to do with the blocks or a page of memory actually was a fixed size. I think it was a half a megabyte, 512K. And it was a fixed size, whatever it was. So they're also called pages of memory. Okay. So anyway, what are in these blocks of memory? So what's in the blocks of memories are different methods running. Now these methods running are not from the same. Okay, we're taking the perspective from the same program, but they aren't all running at the same time, as we'll point out. Right? There's no parallel processing. Only one of these is actually active, but well, they're all okay. They're all active in the sense they're all activated, so they're all in use, but they're not all active in that the code from each are not necessarily all running at the same time. Anyway, here we go. So we'll show you a scenario of this drawing here, but in Excel, of course, everything's square, not circular or random morphous, random curved. Anyway, here it is. So we're using boxes. So there are 4 blocks of memory, each assigned to a method. The method's named next to it. Block 1 is main, block 2 is F, block 3 is G, block 4 is H. Now, so this block of memory assigned to the method, in order to enable a method call, what type of information would you normally store in there? So this block of method will have, for example, a parameter list. When you call your method, whether it be main, F, G, or H, typically, the major majority of times, send values, inputs to those functions, to those methods. Now those values have to be stored somewhere. So that's what's called the parameter list. So you'll store all those values in that parameter list, that area in the block of memory owned by your method, which means as soon as the method is completed, then that memory is released, and those values are, well, in some sense gone, but not necessarily, because those values are still in the memory. It's just that the operating system does not have a record that someone owns that area of memory or is using that area of memory. Those values are still there. No, when you finish your code, no operating system function writes zeros and erases everything. So you think it's gone, it's actually there. It just may be very hard to find. Anyway, the parameter list. Now code. So this was an interesting one. In the early years of computer science, where the codes were very small, as I recall, the actual code was stored in the block of memory. Obviously, today we don't do we store an address to where the code is stored. The code has to be somewhere. Right, so as I point out here, the star on the right, the note says whether the actual code or the pointer to the code. But you need some memory to tell us where to go to get the code for implementation of this method, mange, fg, or h. Okay, now you, as a programmer, of course, you may have declared local variables, right? But where's that memory? So again, that memory is also in the block. So local variables. Okay, now just an interesting point here. If the variables are static, then as you know, they're always available even after you leave the method. So that permanence, quote unquote permanence, meaning they're available after the method is finished, gives it almost a global status. So then that's very interesting because that can mess. The reason I'm pointing this out, we don't have time to analyze this, but hopefully in programming languages and in operating systems, this, because this causes a problem. You see, in the old years, local variables were stored in block form. So now, if I'm not saying it's true, but if local variables can have static form, then that means this block has to always remain, and that would be a very big waste of memory, right? Because the local variables, static variables, remain always during the entire running of the program, even when you're not in the method, and even when you exited the method, those values are still there. But if they're stored in the same block, then that means that block has to be there always. So that's a problem. Which led a lot of object-oriented programming languages to say that you can't do static in a non-static method. Okay, so James, okay, in 2 seconds I'm going to show you the runtime stack. The fact is, these blocks, years ago, the blocks themselves go on the stack. I think nowadays they only put pointers to the block. So bottom line, James, is you and I are saying the same thing. We're just dealing with it from a different historical perspective. Bottom line, James, is you and I are saying the same thing. Give me a minute. You'll see your stack. You'll see where they are. Trust me. So I guess to be complete, if I'm not mistaken, I believe it is most OO languages consider declaring a local variable as a static to be an error unless the method is also static. In which case, if the method is also static, then that block is static. It has to always be there. If that block is always there, then you don't have to worry because that slot of memory is there. Otherwise, there's a problem. Anyway, that's beyond us. But do keep we are talking about things. It's just that little detail, which is important, doesn't affect us, not in the computer theory or what we need to understand. Finally, workspace, and the triple star says, the note on the right says, for local calculations, what's also called workspace or scrap space. Right? If you have, for example, if you have a input to a method, and the input is 2 times x times y. Okay? As an input to a method. So that, for example, needs room because you have to calculate 2 times x times y. Where are you going to calculate that? You can't use x and y to do that. And so the answer is there has to be some memory locally that is doing the calculation for you before it submits the final value, the computed value, to the method. All right. Anyway, so that's the basic idea of what these blocks. Now we'll put them in action. Right now they're just sitting there and explaining what they're expecting, but now let's put them in action. Okay. One other point, just to get it out of the way, what happens when the operating system has no more allotted memory in the heap to allocate, assign to a method or function, or procedure or process? Right? No more memory left. There's just so many programs running, and some what are called memory hogs, right? They're eating up, taking access and access to all these memories, and there's just not enough memory left. So that is what's called garbage. That invokes what's called garbage collection. Any block of memory assigned to a method that is no longer active can be reallocated to a different method. Okay, so it looks through the list of all these blocks of memory, and it sees it notes which one of those no longer is connected to a method which is no longer running because the program is no longer running. Now, in the polite programmer approach, the etiquette of programming is you're supposed to deallocate. But off record, I don't know how much programmers actually deallocate their memory. Deallocate would be to tell the computer, the operating system, okay, I no longer need this memory. So that would soften the situation. But regardless, garbage collection is provided by every operating system and even by some languages such as Java. All right, and you should cross-reference if you want the smart pointers in C++. Right, pointer variable itself keeps track of who's referencing it, so that the pointer internally evokes the garbage collection or returns or deallocates the memory. So it does it for you. Anyway, that's really only in C++. I'm not sure in other languages that can do that. All right, so now what we're going to have is we're going to have three scenarios of method calls, and we're going to analyze all the interaction with this heap, and two, compare and contrast each to each other. And this is going to give us a bigger insight into what recursion is or isn't. Scenario number one, and it's the generic method call. I say it's arbitrary because we don't mean non-recursive specifically. We certainly don't mean recursive specifically. We just mean any method call without you thinking as to what it is, right? Any method call. All right, so as James pointed out, that these blocks of memory are either put on or have pointers put on the activation stack. And that activation stack is maintained by the operating system memory manager that keeps track of which method, I'm reading 538, keeps track of which method is calling which method. Each time a method calls a method, a block of memory is reserved on heap and placed on the stack. The top of the stack, and that's what James said, on line 59 is what James said, and the top of the stack is the current active method. All right, so let's take a picture here. Oh, shame. Nice, but okay, let me make it smaller so you can see the picture better. No, I need a little more. One drop more. Okay, there we go. All right, so here we have our scenario. So in our scenario, what happened? You called main. You always call main, right? So you call. We'll ignore the comments on the right. Let's concentrate on the picture first. So the bottom line is when you start from scratch. That the bottom line on line 60 here, that long horizontal line. And now we're going to put a block because you call main. So the main is going to have a lot of pieces. And as we mentioned above, or we showed above, there are at least four sections in the block of memory. The parameter list, room for the parameter list, room for the code or pointer to code, room for local variables, and room for general workspace. All right, so we're going to put the main on this thing here. Okay, and then main is going to call another. Main is calling another another method. Okay, so maybe I'm hoping using different colors makes it a little bit easier to analyze. So along the way, y equals f of x. Okay, ignore the right hand side. Ignore that. All right, so then we have to pause because main is calling f, and main cannot continue till f returns a value, right? So then a block of memory has to be associated with f, and that block of memory, let's use a different color, and that block of memory is then pushed onto the stack, and then along that way, now G of X is called, rather. So we suspend F. We already suspended main because main is waiting for F, but now we're suspending F because F is waiting for G. All right, so now we have G, and a block of memory is now put aside for G, and now along the way we call H. Now, okay, so G is suspended, and again a new block of memory for H, and finally running out of colors here. Let's see what's a nice color. Brown wasn't that bad. I'm trying to use a slightly different color. Let's see here. That's too dark. You said. All right. All right, so then we have a fine. Now, so I just want you can associate each block separately. That's what I'm trying to do. Okay, so we have 4 blocks corresponding to the 4. That's interesting. Maybe I should coordinate it this way. So then you'll understand the 4 different ones. Give me 1 second. I'm not going to use green. All right, one last one, and then we'll get back. 1 second. Good. All right, so now H is called, but then H, in this scenario at least, H has no more method calls. Okay, now we're going to read on the right side next to this drawing. So H has no more method calls and no more method calls, which means H is going to go to completion. If it goes to completion, so then I write, upon H's completion, the block is popped, this block is popped, and the output value is returned to GX. Okay, so now G is on top, and it's waiting on line 47, Y equals H of X. But we now got H, so now we got Y, which means G could go to completion. Now we read on line 50 on the right, upon G's completion, the block is popped, and output value is returned to F. Okay, so this block is popped, and F is on top. Now F was waiting for G, but we just completed G. G returned the value. So now this line is completed and goes all the way down to line 55, where we write then, upon F's completion, the block is popped from the activation stack, and output value is returned to main. And believe it or not, generally main is considered as having arguments, argc, argv. So now main is now on line 56. Main is now is on top, right? It is the only method block on the stack at this point. It was waiting around for F, Y equals F of X on line 57, but we don't have to because F is complete. So F returned the value, and then main could go to completion. At that point, the main is popped. So you don't think of it in those terms, but main is actually popped. And a value is returned to the operating system. This is different than the above. It's different is that it's not an output value of the. It's not an output value of the program. It's a value that to tell the operating system whether. A. Let's read this note. To the user, main is a void. For example. Let me rephrase that. Main went through a number of historical iterations as to whether it's int or void. But anyway, to the user, main, I think now the current way of doing it is void. To use main is a void, no return value, but to the operating system, main is an int. Returns a semaphore flag, commenting on whether the program executed till completion without problems. And that good semaphore actually is -1. -1 is the convention to say that it's good. Okay? Let me just change the block to its block. Okay, very good. Right, so that is what's called a general method call. Now, so now we're going to enter into scenario 2. I'm copying over the heap over again. So just to remind you, That in the following scenario, though, so to remind you that the following. Oh, wait 1 second. Yeah, okay. So this is a repeat of the original, the first one, just to remind you. All right, as I just repeat, I don't know why. All right, fine. To remind you one more time what the idea is. All right, scenario number 2. Now, scenario number 2 is a little bit different. Give me 1 second. So this is going to be interesting. I don't know if I'm hoping this makes it easier for you instead of confusing for you. Okay, so, oh, sorry, someone texted. Oh, 1 second. What's going on here? Okay, fine. Natasha, oh, I'm sorry. Let me see these comments. Right. Natasha says, isn't main block at the bottom? It is. Correct. That's true. So it pops after its previous pops out of the stack. But main only pops once the ones on top of it pops. Right? You remove from the top of the stack. Right? The top, that's why it's called top of the stack. Top. Right? So you pop from the top of the stack. In our scenario, we only removed main after H, G, and F in that order was removed. Right? Here, take a look again above. H is popped, right? Upon H line 35, upon H's completion, its block is popped, and now you go back to G's block. Upon G's completion, its block is popped, and you go back to F's block. Upon F's completion, its block is popped, and now you go back to main's block. And then finally, upon main's completion, its block is popped. Right, so we were very clear, I hope we are, Natasha, that you only remove main once the ones on top of it, namely in our case, H, G, and F, are removed. That's right, correct, yeah. It's a stack, so it's the one that entered first, but first in, last out, and that's what stack fashion is, yes. All right, so the scenario here is a little bit different. F calls G, but then G calls F again. All right, so then you have the following. So you call F again. Now, please understand that although the code is identical for the first F and the second F, they are separate blocks. There are 2 blocks called F, as I point out in this picture below it. Block 1 is main, block 2 is F, but the first instance of F, the first copy of the instance or copy of F. Block 3 is G, but then block 4 is the second instance of F. So main is called a push on the stack, but then you're going to pause pause main, because you now have to push F on the stack. F is pushed. Along the way comes G. F calls G, so then you suspend F, and you push G. Memory for G, and you push G on the stack, right? But now G calls F. So now G is suspended, and now you call F. But in this version, the F has no one to call. It's just straight calculations, and then or what we call the base case. As an induction, that would be called the base case. You don't have any method calls, and now you just you will calculate and return. Okay, so no more method calls. So upon second F's completion, its block is returned. Output is returned to G. Its block is popped, return to the heap, and output. Well, that's a question again. Return to the heap. It's supposed to be returned to the heap. Okay, let's leave it alone. Again, because of garbage collection, not everyone returns it to the heap, but it's supposed to be. Its block is popped and output returned to G. Then upon G's completion, the block is popped and output value returned to first F of X. Right? And then upon first F's completion, its block is popped and its value returned to main. Okay, so now okay. All right, and now it's turned to main, and finally, same thing Copy that over. Actually, the way I wrote it above is better. Let's just copy this over. Completion, its block is popped, and the value and the semaphore value is returned to the operating system. Okay, it's up to you to print to the output value to the outside world. Main doesn't do that for you. All right, so main calls F, F calls G, G calls F, and F doesn't call anybody, right? So that's what's going on. Well, I don't know what's going on there. Hold on a second, let me just quickly change this. Something of the, I have to figure out which one it is. No, use this one. Hope it's this one. Alright, hope it's that one. Good. Now, alright, so the reason I'm bringing up scenario 2, of course, is, which I ask above, okay, is this recursion, which is, well, okay. This scenario is what's going to be called indirect recursion. The question is it a recursion? Okay, what's the issue? N calls F, F calls G, and G calls F. But if you look at the top, on line 2, we said it's a function or method that calls itself. Right? A function or method that calls itself. So, is that recursion? Because in our scenario number 2, main calls F, F calls G, so far so good, but then G calls F. So individually, main calling F, in scenario 2, main calls F. Is that recursion? No. F calls G. Is that recursion? No. G calls F. Is that recursion? No. Because you defined it as a function or method that calls itself. So the question to ask is, but if you look at it, a wholesome approach isn't the whole the sum of its parts. Because as the sum of its parts, F does lead to a call to F. It just does it in the scenic route, as they say, by going around and through other calls along the way. So should scenario number 2 be considered recursion? Okay, so let's pause that for a second. Now I'm curious to think about it. I'm curious what you're going to say, but let's now go into the next situation. So this is for the above case, and we're going to have our last case, where it's F calls F, which of course I think you recognize as being recursion. Just copy this over. So you have main, and then you have your block. Right, but then you're actually going to call F again. So F is going to be called 3 times. The last time, right, F is called 3 times. The last time is unnecessary because, it's not going to be called because that's the base case. Triggers the base case and no more method calls, as I write in line 125. All right? All right, so here we go again. So let's review. Main calls F. F calls F first time. Main calls F. So that's the first block. F calls F second time. Second time the F is called. And then one last time, F calls F third time. Okay, so upon third F's completion, its block is popped. And the value is returned to the second F's block. Right? Upon second F's completion, its block is popped, and the output value is returned to first F of X. Upon first F of X completion, its block is popped, and the output value is returned to the main, and then just like this is worded better over here. Let me copy this. Upon completion, the operating system, the main leaves popped from the activation stack, and then a semaphore flag value is sent to the operating system to indicate that everything went well. All right, and here's our picture in the heap. Namely, Main, F first instance, F second instance, and F third instance. Okay? Now, some interesting things to point out here. First of all, as an abstract data type, a stack is only interacted by the top of the stack, right? Take the general scenario here of where we have a block 4, block 3, 2, and 1, right? And block, let's imagine, as well as I show in the code, block 3 has y equals h of x, block 2 has y equal g of x, and the main has y equals f of x. But we don't see necessarily, at least I didn't show it, so you can assume y is not operating in that h, right? Or maybe it is. Let's say, for example, well, certainly no method call is operating here, right? But it could have y equals 7, right? Could be. But that's not a method call. So y could appear absolutely everywhere. Now, what's the issue? This is unbelievable. And what does that have to do with abstract data? I'll tell you in a second. This is unbelievable. Imagine that when H on the top of that stack has Y, Y not declared. So you would presume that that is a error, right? You have a variable that was not declared. So believe it or not, there are a number of different. I couldn't document, but I know this for a fact it did occur. So hopefully in your programming languages they'll point this out. But in some operating systems, in order to what the operating system developers thought was helping the programmer, if Y is not declared in the top of the stack, the operating system will descend in the activation stack and find where Y is declared. Let's say you forgot Y equals 7 and did not declare it there. You did not declare it in H, you did not declare it in G, but you declared it in F. Believe it or not, that operating system is going to consider the Y's in H and G to be the Y that was declared in F, and it will not give an error. That is terrible. That makes it almost impossible to debug, right? It would be easier for the programmer, I think, if H and G an error. You use Y that was not declared, local variable. But our operating systems, believe it or not, that will violate the ADT, abstract data type approach, which means, because what are they doing? The stack isn't treated as a stack, which says you only can access the top method. Instead, you go down and the stack as if it were a linked list, which is an implementation detail, find the block where Y was declared, and then say everybody above it is referring to that variable. Very sad, but unfortunately true. Now, that's one point. Second point. The second point is dealing with the indirect recursion and the asterisk on line 2. So I will give you a story, which was the code I have here on the tab code. You can look at it later. It has to do with factorial. This actually happened to me in high school, believe it or not. I was taking a computer science course in high school. And the teacher wanted us to compute something like factorial. Factorial, I guess, yeah. Now, I knew mathematically that factorial is defined by n factorial equals n times, fact of n equals n times fact of n minus 1. It's a classic example. Here, I'll show you in the code. It's a classic example of recursion, right? Ignoring whether, I didn't use names, F and N, you really shouldn't do that. You should give it good names. F should say factorial, N should say number, etc. Okay, I'd put those in the notes, that the naming is not great, not software engineering standards. But the first section is the recursive code. Basically, base case is 0 factorial is 1, and then n and return n times f of n minus 1. Right? Recursive code for factorial. Right? Very straightforward. Now, what was the issue? The issue was the following, that the compiler, the manual for the compiler, when we went to high school, said that recursion is not allowed. Okay? Recursion is not allowed. The school wanted to save money, or maybe they got a donation from the company, but the company didn't want to have that for free, that you get every feature. Anyway, that's what it said. Recursion is not allowed. What does it mean to be recursion? I look at it, and the definition is like a function that calls itself, right? I look it up in the book, and the book says what we just wrote. It's a function that calls itself, right? Over here, function that calls itself. So I asked myself, well, according to that, scenario 2 should not be recursion. And that's the code I wrote. I give you the code that I wrote in high school. F calls G, G calls F, and that's it. Here's the code, the equivalent code. Okay? All right, I forgot it. So something like that. All right. There it is. So basically, it's the exact same code, but the G that I use does nothing except call n. G of n calls f of n. If f of n, if n base case identical, instead of return times g of f of n minus 1, I do return n times f of n minus 1, and g of n. Instead of n times f of n minus 1, I do return I would say return n times gn minus 1, and all g does is exactly what f does. It does nothing else. It's what's sometimes called a wrapper function. I didn't know that at the time. Anyway, I came up with this idea thinking, well, according to the definition in the book, a function that calls itself, this doesn't call itself. Lo and behold, it worked. It worked. The compiler that said that the compiler will not allow recursion allowed my situation. So I didn't have to think about calculations. I got done right away. So that's the question. Indirect recursion, is it recursion or not? So what I have to do with this asterisk, because what we really mean is a function that eventually calls itself, parentheses, that will come to call itself, not necessarily immediately. Point is that indirect recursion ought to be recursion, as I found out in high school, but technically isn't. So, it's like we mentioned, I think we mentioned this class, partial functions is partially recursive. So what they called this, they gave it a name, they called it indirect recursion. It is, but it isn't. So that's the asterisk. The asterisk from line above. I don't know where to say it. Okay, where should we say it? Okay. It's a note. Okay. The recursion, a function method that indirectly or eventually calls itself. That's the extra word from line 2. Okay. That's what I was referring to, Elio. Okay, cross-reference line 2 above. All right, so as a summary, let's say the following. Let's sum up, and then we're done for tonight. In conclusion, 1, the operating system does not treat any of these scenarios different than any other. Differently than any other, right? Whether F calls G calls H, F calls G calls F, F calls F calls F, and that's why I emphasize this. The pictures all look the same. Operating system doesn't treat anything necessarily differently, because of the fact it's one scenario versus the other. Okay, the first scenario being arbitrary method calls, second scenario being indirect recursion, third scenario, of course, being recursion. Okay, that's point number 1. Point number 2. All 3 scenarios are instances of method calls. The latter 2 are specialized, but still are method calls. If this is sort of, hindsight 2020, it's an obvious comment. It's just I've had students on exams who, under pressure, confuse that. When we say scenario number 1 is a method call, it's a general method call. That does not mean that the scenario 2 and 3 are not method calls. They're just special method calls called recursion or indirect recursion. But they are also method calls. Okay? And they also involve, but still are method calls and involve method calls. Okay. last one. This last one I mentioned, so I wrote it above. I mentioned this to you, so I don't have to repeat it. But anyway, the point is that some operating systems, when a variable is not defined, will descend in the activation step to find where, as I say, descend, find where it's declared. Anyway, I wrote that up as number 3. Okay, so that's it. So I'm going to send you this with the paper choice information tab 1, the notes from today's lecture in tab 2, and the code for the indirect recursion. You can test out yourself in tab 3. All right, so let's see if there's... Other than that, please text that you are present, and that's the end of today. All right, so let me see what people say here. Okay, James says the following. So if I say f of x, g of x, h of x,